Alright, today we're going to graph quadratic functions in vertex or intercept form. Specifically today we're going to talk about vertex form. Okay, and in vertex form, it's very similar to what we did with absolute values, where h and k are very important to our vertex, okay, because they are the vertex, and where h is actually the opposite of what you think it is, okay? Once again, just like yesterday, the axis of symmetry will be exactly through the vertex, okay? So that's not going to change. Also, the same rules apply to A. Okay, if it's positive, it will open to the top and it will hold water. If it's negative, it'll open downwards and it'll spill water. Okay, in this case, we would have a minimum because the vertex is the lowest point. In this case, a maximum. All right, so these are things that we're all going to learn in vertex form. This is going to be an even faster way to graph parabolas. Okay, very, very similar to absolute values. Okay, so this is what we're going to do. This is how we're going to graph a quadratic in vertex form. First, we're going to plot the vertex, okay, and that's hk. All right, and h is the opposite of what you think it is, and k is exactly what you think it is, just like an absolute value. All right, we're going to pick two values on one side of the vertex and solve for those two values in a t-chart. Okay, so we're going back to our t-chart days. We're going to go ahead and solve for two values so that we have two values on the right hand side. Okay, we're going to draw our axis of symmetry through our vertex, and we're going to plot the points and reflect two more points on the other side. All right, so this is debatable between yesterday's method and today's method, which way is faster, but we're going to go through it, and this is called vertex form. Okay, so let's take a look at this graph here, and it says graph the function and label the vertex and axis of symmetry. Now just remember, our vertex form would be y equals a times x minus h squared plus k. All right, and so what we have here is the vertex should be hk. In this case, h is always, in every case, h is the opposite of what you think it is, 3, and k is exactly what you think it is, -4. So just like an absolute value, okay, we're going to find the vertex just by looking at h and k. And what I'm going to do is I'm going to go ahead and start by plotting that. 1, 2, 3, -4, right there. I'm going to go ahead and draw my axis of symmetry in as well. All right, I'm going to label that axis of symmetry. That's not actually part of the graph, it's just more of a reference line. Okay, and I'm going to start making a little t-chart here. I don't want to overdo it, I just want to do a few quick numbers, all right? I'm going to pick a few numbers that are going to be easy for me near my parabola vertex. So right now I'm at 3. I'm going to pick 4 and 5 as x values and just see what those give me and then go from there. Okay, so I want you to just pick two values next to your axis of symmetry. Let's say 4 and 5 in this case. Okay, one more time, I got those because I'm at 3 now. I need a couple more points, so I'm going to plug in 4 and 5. When I plug in 4 and 5, here's what happens. F of 4 equals 1/2 times 4 minus 3 squared minus 4. So f of 4 equals 1/2 times 1 squared minus 4. F of 4 must equal 1/2 times 1 minus 4, which equals 1/2 minus 4. But really we know 4 is really 8/2, so we can say -7/2 is when x is 4, y is -7/2. And so let's do the same thing for when when x is 5. We'll take 1/2 times 5 minus 3 squared minus 4. And so we'll continue on through all the work here. And I'll just work it out for you so you can kind of see what's going on. Make sure you square it before you multiply. You need to follow order of operations still. 2 minus 4, so f of 5 actually equals -2. And there's all the work that I did for it. So f of 5 equals -2. All right, so I have these additional points on my graph. At 4 -7/2, 1, 2, 3, 4, you can actually think of it as -3.5 if you'd like. Okay, and I also have 5 -2 right here. And as you can see, I only have three dots. However, I know because I have the axis of symmetry on my graph that there's also points in the exact opposite. So without doing those points in a t-chart, I know I can just connect the dots and make my parabola. And as you can see, it agrees with my A value. It was positive. It was between 0 and 1, positive or negative between 0 and 1. Okay, so it made it a little bit wider than usual. Okay, and my vertex is in the right spot at 3, -4. All right, so there's a little bit of t-chart work to do in these. However, it's a great method to graph parabolas or quadratics if it's already in the form. Okay, so let's look at another one here. In this case, once again, I'm looking at y equals a x minus h squared plus k, and my vertex is hk. H is the opposite of what you think it is, so I'm going to say -2, and k is -3. It's exactly what you think it is. So let's start there on my graph here at -2, -3. Put my first point. I'm also going to draw my axis of symmetry because it always goes through the vertex. Label that. Okay. I can't remember if I labeled the min or the max on the last one, but you may have to go back and do that as well. And I'll remind you about that here in a second. But what I want to do from here is I need to pick a couple points to plug in on either side of my vertex. You can pick, since we're at -2, maybe we could pick -3, -4, or you could pick -1 and 0. Whatever you prefer. I think -1 and 0 will be easier to plug in. That's why I'm going to pick -1 and 0. But you can do whatever you want. -1 and 0 are just 2 points next to my axis of symmetry. I'll show you again. Here's -2. I just need a couple more points to help me draw my graph. So I'm going to plug in -1 and 0. Y equals -1 plus 2 squared minus 3. So y equals 1 squared minus 3. 1 minus 3. Y equals -2. So there's another point on my graph. And finally, let's just do one more. Okay. Y equals 0 plus 2 squared minus 3. So y equals 2 squared minus 3. Y equals 4 minus 3, so y equals 1. All right, so now thanks to my t-chart, a little work here, and I have the 2 points, -1, -2, and 0, 1. And because I already have my axis of symmetry drawn, I know that these points are also reflected on the other side. So I'm going to go ahead and put those on there as well. Now when I connect the dots, I have a nice looking parabola here. Okay, nice looking quadratic. And it agrees, once again, my A value wasn't really obvious this time. It was 1, it's positive. It's holding water, so that's good. Okay, it also says, now that I remind myself, to label the vertex. The vertex is right here. It's at -2, -3. I've labeled it over here, but I also want you to put whether it's a minimum or a maximum. Because the vertex is the lowest point on the graph, it's going to be a minimum this time. All right. So we've done all this stuff, and we got a pretty good looking graph. Let's look at another one here. Okay. And same structure, same idea. Okay. Y equals A times X minus H squared plus K. HK is my vertex. So I'm going to say it's at 1, 5. Now remember, this is the opposite. This is exactly what you think it is. So I'm going to start there at 1, 5. I'm going to draw not only my vertex, but my axis of symmetry. Okay, label it axis of symmetry so I don't get confused. That's not part of my graph. It's just a reference point. And because this time I'm at 1 right here, let's just pick 2 and 3. Those look like pretty easy points. Let's just pick a couple more points to throw in there, okay? And find a few more points, and we can always reflect them. 2 and 3. So we'll say y equals -2 minus 1 squared plus 5. Y equals -1 squared plus 5. Y equals -1 plus 5. So y must equal 4. -1 plus 5 is 4. All right, and we'll do a little more work here. And I'm sure you can work it out a little faster than me. I'm just going to go ahead and show all my work so no one gets confused. 3 minus 1 squared plus 5. Okay, I'm going to do a little work here. Y equals -2 squared plus 5. Y equals 1. Okay, so I have 2 more points now. I have 2, 4, and 3, 1. I'm going to go ahead and plot those points. 2, 4, 3, 1. And because I know that parabolas are reflected across the axis of symmetry, I can also put them on the other side. And as you can see, it's nice and symmetric. Okay, it makes a nice parabola. It agrees with my a value, which is negative. Okay, so it should open down. And we just now need to label the vertex right here. Okay, we know our vertex is at 1, 5. And this time it's actually going to be a maximum vertex, because this is the highest point on the graph. Okay, nothing goes above that vertex, so it's the maximum point on the graph. All right, let's take another look here. Okay, this one's a little different looking. Okay, and we did some of this in absolute value. I keep referring back to that. Okay, and the vertex is going to be HK. And once again, we have an H here. It's the opposite of what you think. However, we're missing a K value. So what we can always do, if it really bothers you, we can add a 0 on there without changing anything. So we're going to call it the K value 0. Okay, so I'm going to start with my vertex at negative 1, 0. All right, and we love fractions, so let's plug in a couple points. Now, I'm going to draw my axis of symmetry, dotted line. It's not actually part of my solutions. I just want to label it there. It's a reference point. I'm at negative 1 now. I don't like dealing with negative numbers, so I'm not going to pick negative 2, negative 3. I'm actually just going to pick 0 and 1. Let's just pick 0 and 1, see what happens when we plug those in, and see where our points are. My XYT chart, 0 and 1. Y equals 1/2, 0 plus 1 squared. So y equals 1/2 times 1 squared. So that's 1/2. 0, 1/2 is one of the points. Now let's plug in 1 and see what happens. We have y equals 1/2, 1 plus 1 squared. So y equals 2. Okay. So we got something good going here. We have two new points, 0, 1/2, and 1, 2. I'm going to go back to my graph, and I'm going to go ahead and plot those as well. And you can either connect your dots there. Usually I like to reflect first, get my other side in there. Okay, got a nice looking parabola going here. It's actually going to be more like this. It's going to keep going out like that. Poor sketch. Okay, it's going to be more like that guy right there. This isn't very accurate. Okay, and we now have to just label the minimum or the maximum. The vertex is here. We already labeled it. We know what it is. It's negative 1, 0. It's going to be a minimum this time because it's the lowest point on the graph. No part of the graph ever goes below that. It's the lowest and the minimum point. Okay, let's just do one more. Okay, this one's really tricky because it's not obvious that it's in vertex form. However, vertex form does apply here if you'd like to use it. What we have is y equals a x minus h squared plus k. And as you notice here, the vertex is always hk, but we're missing an h value. We don't have a number inside this with the x. So I'm going to just go ahead and call the h value 0 and the k value 1. So my vertex is going to be 0, 1. Okay, so that's the real hard part to see. Okay, this is in vertex form. You just got to be careful. There's nothing in here with the x, so we could subtract 0 from it or add 0 to it. Either way, the x coordinate of the vertex is still going to be 0. So we're going to start at 0, 1, put our first point. Hey, right on the y-axis. All right, and so let's draw our axis of symmetry. It actually goes right through the y-axis. All right, and let's just pick a couple points to plug in to a t-chart to find a few more points to use here. Okay, so I'm at 0 right now. Let's just pick 1 and 2 as my x coordinates. All right, and we'll just plug them in here. F of 1 equals 1 squared plus 1. F of 1 equals 1 plus 1, which equals 2. And we'll plug in 2. F of 2 equals 2 squared plus 1. Okay, F of 2 is 5. So we have 2 more points from our t-chart. we know the point 1, 2 and 2, 5 are both also on the graph. Okay, and because we have this axis of symmetry and we know parabolas are symmetrical across it, we can reflect a few points on the other side without doing the t-chart for them. And we're going to connect our dots here. And finally, my vertex is going to be a minimum value at 0, 1 because it's the lowest point on the graph. Okay, it's the lowest point on the graph.